Hey y'all, so today we're going over quadratic functions and their properties. So there's two different ways to write a quadratic equation. The quadratic function of ax squared plus bx plus c, or the vertex form of a times x minus h squared plus k, and hk is our vertex. So in this first example, we're going to find the vertex and axis of symmetry, and we're going to put the quadratic function into vertex form and state those transformations we would make to our graph. So let's start by putting it in vertex form. So to convert to vertex form, we need to complete the square. But we know our a value. So our a value is what's in front. So 2, and then we're just going to look at the x part. So if we factor a 2 out, we would have x squared plus 4x. And then we're going to close that and put the plus 5 because that's our c. So our 5 is going to stay on the end. Now we're going to continue completing the square. So inside the parentheses here, we want it to be a perfect square. And if you remember doing that, that's that b over 2 squared. B is our 4. So bx. So 4 divided by 2 squared. That's 2 squared, which equals 4. So 2x squared plus 4x plus 4, which we just got, and then plus 5. And then since we factored that 2 out, we have to do minus 2 times the 4. So since we factored the 2 out, we have a 2. And since we put a 4 here, we also have to put the 4 there. And it's minus because since we're adding it on this part here, we have to subtract it from the end. All right. So to continue on to, I'm going to do 5 minus 2 times 4, so 2 times 4 is 8, and 5 minus 8 is 3. And then I'm going to factor what's in my parentheses. Now it's a perfect square, so now we just need to know what times what gives us 4, and that's 2. So 2x plus 2 squared minus 3. So now that we're in this form, it tells us our vertex, and we can talk about the transformations. So h would be -2 because that's always opposite of what's inside the parentheses, and then k equals -3. So our vertex is -2, -3. The axis of symmetry is x equals h, so our axis of symmetry is -2. So axis of sim is x equals h, so x equals -2. Then we're going to talk about the transformations. So we have the 2 in the front. So we're going to multiply by 2. And always start with your compressions and stretches. Then let's go with the 2 here. So we go left 2, and then -3 on the outside of the parentheses, down 3. So I'm going to shrink this all a bit so we can add our graph in here. So multiply by 2, so it's going to be thinner, and then left 2, down 3, and then something like this. And that would be a sketch of our final graph. Next, locate the vertex of f of x equals negative 3x squared plus 6x plus 1. Does it open up or down? Do not graph to find out. So another way to find our vertex is by doing negative b over 2a, and then whatever you get when doing negative b over 2a, you plug back into the function to find your y value. And then if your a value is greater than 0, it opens up, and if a is less than 0, it opens down. So when we go ahead and find this, we're going to do negative, let's label our values. So a equals negative 3, b is 6, and c is 1. So when I plug into the formula, negative 6 over 2 times a, so negative 6 over negative 6 equals 1. Then that's our x value. Now to find the y value, I'm going to plug it back into our function. So negative 3 times 1 squared plus 6 times 1 plus 1. So y equals negative 3 plus 6 plus 1. Y equals 4. So our vertex point is 1, 4. And then lastly, and we'll label vertex. Does it open up or down? Our a was negative, so this graph is going to open down. I really did not spell that right at all. D-O-W-N. Okay. Discriminant. So the discriminant, when we're talking about this, tells us how many solutions or x-intercepts this graph has for a quadratic. And that's part of the quadratic equation when we do b squared minus 4ac. So if we get a positive number when we do b squared minus 4ac, that means there's going to be 2 x-intercepts, or 2 roots, 2 solutions. B squared minus 4ac equals 0. That means we're only going to have 1. And then when it's less than 0, so when we have a negative number, we're going to have no x-intercepts at all. So if you end up having no x-intercepts, you want to do a table of values so you can get points to graph your graph. So let's look at this example. Graph negative 3x squared plus 6x plus 1. Using its properties, determine the domain and range. Determine whether f is increasing or decreasing. So first of all, we know from above that last problem we did is the same. It's the same equation. So we know it opens down. And 2, we know the vertex is 1, 4, and the axis of symmetry is x equals 1. Okay? Yep. All right. So 3, we're going to find the intercepts. So the y is when we plug x equals 0 in. So the y int. So that would be negative 3, 0 squared, plus 6 times 0 plus 1. And that equals 1. So our point is 0, 1. And then for the x-intercepts, we're going to do the quadratic formula. So negative b, and I'll write the quadratic formula up here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't know if y'all have heard the song yet for quadratic formula, but maybe I'll play it in class. So let's plug in our values. So negative b would be negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times a times c would be plus 12 all over 2 times a, which is negative 6. You can already tell our b squared minus 4ac is whatever, so that is the inside the radical part. That's going to be positive, so we're going to have 2 solutions. When I plug this in my calculator, I get the 2 points of x is negative 0.15, and I also get 2.150. So now with all this information, the vertex, knowing that it opens up or down, and those intercepts, we can go ahead and graph our equation. Okay, so our y-intercept at 0, 1. Then we have an x-intercept at about 2.15 and 1, at negative 0.15. And then we have our vertex at 1, 4. And now I know it opens down. So when I connect my dots, I'm going to make sure that it opens down. And there it is. Now to determine the domain and range. The domain for quadratics are always all real numbers. The range, we have this max point at 1, 4. So y is going to be less than or equal to 4. It is increase from negative infinity to the x value of 1, and then it decreases from 1 to infinity. So here's our increase, here's our decrease. And next, determine the quadratic function whose vertex is 1, 5 and whose y-intercept is negative 3. So we can use the f of x equals a x plus h squared plus k to find this, since we know a point and we know the vertex. So since we know the vertex is 1, 5, then we know h equals negative 1, k equals 5, and then if the y-intercept is negative 3, that means the point is 0, negative 3. So x would equal 0, and y equals negative 3. Knowing all this information, I'm going to go ahead and plug it into our equation. So y equals a, since we don't know a yet, but we know x is 0. We know h is negative 1, so minus negative 1, or h is actually positive 1. So when we do minus h, it's minus 1, and then squared, and then plus 5. Now we're going to simplify and solve for a. Also, we knew that y was negative 3. So negative 3 equals a. 0 minus 1 is negative 1 squared plus 5. Then we can subtract 5 from both sides. So negative 8 equals a times 1, because negative 1 squared is 1. So that just means a equals negative 8. Now we know a and h and k, so we can make our vertex form. Y equals a, which is negative 8, and then x minus h plus k. So that's our vertex form, but they want the quadratic function, so that ax squared plus bx plus c. So I'm just going to multiply this out. So x minus 1 squared is x minus 2x plus 1 plus 5, and then distribute the negative 8 minus 16x plus 16x minus 8 plus 5. So y equals negative 8x squared plus 16x minus 3. All right. maximum, minimum values occur at vertices. So as we know, our max and min happens at the vertex of our quadratic. So if we have a quadratic that opens down, that's a max point. And if we have one that opens up, that's our minimum point. So let's go ahead and determine whether f of x equals x squared minus 4x minus 5 has a max or min, and then determine what it is. So our a equals 1, and 1 is greater than 0, so this opens up. So that means we are going to have a minimum value. Now we just need to find it by finding the vertex of doing the negative b over 2a. So negative b over 2 times a, so 4 over 2 equals 2, and then plug that back into your function. That's 4 minus 8 minus 5, which is negative 9. So the point would be 2, negative 9. So we have a min value at x equals 2 of, so we have a min, we write it a bit differently, a min at x equals 2, and then of a value of negative 9. And that's it. Let me know if